For test number 2 is I printed off the practice test problems so that I could work them on paper for you so that you can see the work that I would do. But this is exactly the order that they will show up on yours. It's the exact same style of problem. It's just that yours are obviously on Pearson and I printed mine off of Pearson so that I can work them here for you. And then remember, on the notes section on Blackboard, there is a test folder that you can go into, and I have all of my work shown out for a different practice test. Same problems, just different numbers. So don't go trying to match those answers with these problems because they are different. But you do then have 2 different reference points, hopefully, that will help you be successful in this exam. So what we're going to do is I'm just going to work through all of the problems and put the answers in. And that way you have a live lecture of sorts to watch and go back through. If you get stuck on a certain problem, you can skip ahead to that problem, watch me work it, and hopefully that will help you. So number 1 says simplify the expression by combining any like terms. Remember, to be a like term, you have to have the same variable with the same exponent. We have an x here with the exponent of 1, an x here with an exponent of 1. So we have 8x minus 6x. Since they are like terms, we just do the arithmetic with the coefficient or the numerical part of these terms. So 8 minus 6 will give us 2. The x is kind of the designator telling us what we have. It's like we have 8 M&Ms, but we're going to take away 6 M&Ms. We're left with 2 M&Ms. The x's simply tell us that they are M&Ms. One thing to note before I move on to other problems is that printed off, the ID is down here. On the actual practice test, when you're looking at it on Pearson, it'll come up at the top where it says number 1, and then it'll tell you 2.1.9. That last number really doesn't matter to you. It's the first 2 numbers. The first number tells you it's chapter 2. The second number tells you that it's in section 1. So that way, if you do get stuck on a specific problem, you can look at the ID that goes to that problem, and you can go back then to that corresponding homework or that corresponding section to get some review. All right, for number 2, it says combine like terms when possible. If not, rewrite the expression as it is. So if there's nothing to do, we just rewrite it. If there is something to do, then we do that. So in this case, we do have some like terms, because notice here in the middle I have a positive 7m minus a 12m. These are all like terms. They both have m's. So if I have 7 positives but 12 negatives, I have more negatives. How many more negatives do I have? Well, I have 5 of them. So I have a minus 5m. And then on top of that, I have 9 plus 19. These are like terms because they're both constants. So I can combine them further by taking 9 plus 19, which will give me a positive 28. Now, the order does not matter here. I could have put 28 minus 5m. I'd still get the answer correct, because that's our commutative property of addition that we learned about in 1.10. So generally, though, if you have a constant and you have a term that has a variable, it's a good habit to get into to put the variable term first, the constant at the end, but again, you will not be counted wrong if you don't. All right, number 3, use the distributive property to rewrite the expression. The distributive property we learned actually back in section 10 of chapter 1. So the distributive property is where if we can't do anything inside our parentheses, we can take what's outside of it and bring it inside and multiply. So 9 times b will give me a 9b. 9 times 7 will give me 63. And if I had more terms, I'd just keep distributing that inside as well. All right, number 4, the exact same style of problem, but there's no number written out here. There's just a negative. If you're okay with leaving the negative, you can leave that and we distribute the same way. If you want there to be a number, you could write this as negative 1 times negative x plus p. Either way is correct, because we understand that if there's not a number written out in front of a term, it's like there's a 1 there. So either way, you're going to distribute that negative or the negative 1, depending on which way you like to think of it. But a negative times a negative produces a positive, meaning you're going to end up with a positive x. That negative or negative 1 applies to that positive p as well. Negative times positive will give you a negative, and then you'll just have a p. All right, let's look at number 5. It just says simplify. So simplifying here on number 5, that's where we're going to use our distributive property to get rid of our parentheses, and then we will combine like terms as needed. So that 3x right now is just coming along for the ride, but then I am going to distribute that positive 2 to the positive 4x. 2 times 4 is 8, so it'll give me an 8x. Then I take the 2 and distribute it to the 9. 2 times 9, that's 18. So now if I look at this, I do have some like terms in that I have 3x and I have an 8x. Those are like terms. 3 plus 8 is 11x. And then I have the constant of plus 18. I cannot combine these any further. They are not like terms. Number 6 is pretty similar, only this time I have 2 sets of parentheses, so I'm going to have to distribute twice. Because in order to get rid of this first set of parentheses, I have to distribute the 6. So 6 times x will give me 6x. Then I take 6 times negative 2 to give me a negative 12. Then I slide on over to my second set of parentheses. Here I have 3 times 4, which is positive 12, and I distribute the 3 to the negative x, giving me a negative 3x. And then don't forget, we still have this minus 6 out here. A lot of times we get so like rushed or whatever doing our problems that we'll distribute and then we forget, oh wait, the problem wasn't done just because we were done distributing. So be careful there. Now, looking here in the middle, I have a negative 12 and a positive 12. Well, those are going to cancel each other out, so I don't have to worry about those. I do have 6x minus 3x. That'll give me 6 minus 3 is 3. And then I still have that minus 6 here at the end. So just be careful, because this minus 6 out here is the most commonly missed thing, where we distribute, and we just want to combine like terms, and we actually forgot that part of the problem is still there. So be careful with that. All right. Number 7, is p equals negative 18 a solution to 2p minus 5, parentheses p plus 7 equals 19? So this is the beginning of 2.2, where we are testing solutions. We are not asked to solve this at all. We're not even asked to simplify it. All we have to do is anywhere there's a p in here, we're going to put in a negative 18, and we're going to see if we get a true statement out or a false statement out. So instead of 2 times p, I have 2 times negative 18. Minus 5 times, instead of p plus 7, I'll have negative 18 plus 7 equals 19. Now we should do what's inside of our parentheses first, because everything on this left-hand side is going to be done using PEMDAS, and parentheses happen first. This set of parentheses right here is just a multiplication parenthesis. There's nothing for me to do inside. But over here with this parenthesis, I have negative 18 plus 7. I can do something inside of that one. Negative 18 plus 7 simplifies down to negative 11. Now at this point, I have multiplication, subtraction, multiplication, and then equals 19. So I'm going to do multiplication, and I go from left to right. So I'm going to hit multiplication here first with 2 times negative 18. That's going to give me a negative 36. 19. Now, I have to be careful. This says negative 36 minus 5, but then we have minus 5 times negative 11. This is where PEMDAS comes in. Multiplication happens before subtraction. So I'm going to multiply negative 5 times negative 11. Negative times negative is positive. 5 times 11 is 55. Negative 36 plus 55 gives me a positive 19. Notice I get 19 equals 19. That's a true statement. So that means yes, p equals negative 18 is a solution. If I would have gotten anything else on this left-hand side besides 19, if I would have gotten 18, negative 19, negative 2,375, anything else on this side, and it didn't equal 19, then I would have marked no. Solve for the equation. This is our addition property. We have x plus 2 equals 5. No matter what our equation is, we are trying to isolate the variable. So in order to isolate the variable, I need to get x by itself. This says plus 2. To move it over across the equal sign, I do the opposite. The opposite of addition is subtraction. But because we're dealing with equations or equality, if I subtract 2 from the left, I got to subtract 2 from the right. I have to keep it equal or balanced. When I do that, I'm left with just an x on the left-hand side, because 2 minus 2 is 0. Then I have 5 minus 2, which is going to be 3. So x equals 3. And remember, on all of these, you can check it, just like we did on number 7. We can plug in the solution we got into the original equation and make sure that it holds up, make sure that it's true. There, that makes it a little bit better. All right, so let's look at the next one. We have a negative 9 plus w equals 7. This problem's really no different than the last one, except we're using w's instead of x's now. But we want to get the w by itself. So what we're going to do is we are going to do the opposite, which is negative 9. The opposite of minus is addition. If I add 9 to the left, I have to add 9 to the right and keep it equal. The 9's cancel out on the left, leaving me with just my w. Then over here I have 7 plus 9, which is 16. So I find out the w is 16. Number 10, same thing. Negative 3 equals 4 plus x. Want to get x by itself? I have a positive 4 on the right-hand side with that x, so I'm going to do subtraction, which is the opposite. If I subtract 4 from the right, though, I got to subtract 4 from the left. Negative 3 minus 4, I owe you $3 and I owe you 4 more. How much do I owe you? I owe you $7. So x is negative 7. All right, 11. We have 24 equals y minus 6. Got to get my variable by itself. So it's subtracting 6 right now. The opposite of subtraction is addition. But if I do it to one side of my equation, I have to do it to the other. 24 plus 6, that gives me 30. And then y would be completely by itself on the right-hand side. All right, number 12 is when we switch over from our addition property into our multiplication property, into 2.3. So we have 7x equals 42. Now, there's no sign between our 7 and our x. So we understand that this is multiplication that's happening. We have 7 times x. So just like up here we did the opposite to move things back and forth, we're still going to choose to do the opposite here. The opposite of multiplication is division. So instead of multiplying by 7, I'm going to divide by 7. But if I divide by 7 on the left, I have to divide by 7 on the right. Those 7's on the left will cancel out because 7 divided by 7 is 1. And then I have 42 divided by 7 is 6.